Hi, I'm Kathy Enright. I'm the Executive Vice President of the Food and Ag section here at BIO. Welcome to the convention. I'm really pleased today to be able to spend a few minutes with Graham Brookes, the Director of PG Economics in the UK. PG Economics just released their Global Impact Survey yesterday, which quantifies the impact on the environment and the economy around the world from the adoption of biotech crops. Graham, welcome.
Thank you.
Could you tell me a little bit about what PG Economics is and how you go about gathering information for your report?
Yeah, I'm an agricultural economist by training, and I've been undertaking research analysis of the impact of new technology in agriculture now for about 25 years. And over the last 15 years, one of the areas that we've been doing research on is the impact of biotech crops in different countries. Essentially the economic impact at the farm level and the environmental impact in terms of environmental effects associated with pesticide use change and greenhouse gas emission changes.
So this is an annual report that you publish. How do you get your data?
This report that was put in the public domain yesterday is actually the 8th report in a series. We produce it annually. Fundamentally, the main sources of information are other people's work and literature, some of which is specific studies that I've been involved in doing. There is now quite a substantial body of literature which examines especially the economic impact globally, and we use that as the cornerstone of the analysis we use. Now you have to recognise that there isn't a study that covers every trait, every country, so you have to fill in the gaps with analysis and extrapolation. Now we do some of our own primary analysis based on economic data that we can get hold of. The whole object of what we do, though, is to try and make sure that our analysis is representative and accurate as possible.
Thank you. Before we get into a few of the highlights from the report that was released yesterday, can you talk to me about a third set of eyes that looks at this report, the peer review process?
Yeah, because of the controversy that often surrounds the subject of biotech crops, we're conscious of the fact that any piece of work that we do, which is funded by industry, it is important for the credibility of the work to ensure that it's peer reviewed. So we always try and get our work published in reputable peer review economic journals. And we've been successful every year in relation to this project, and I am now actually the author of 15 peer review papers on the impact of biotech crops globally. So I'd like to hope that people think that we know quite a lot about the technology and our analysis is credible.
Terrific, thanks. So with regard to yesterday's report, what are some of the highlights? What should we look for when we go to your report?
If you go to the report, you'll find, in terms of the headline numbers, economic impact at the farm level. Over the 16-year period to 2011, farmers who've used the technology have increased their farm income by over $98 billion US.
And what does that mean for farmers?
At the farm level, that's the equivalent to every farmer who's used it on every hectare, an extra $133 a hectare. So multiply that by 2.5 and you'll get the acre equivalent. I'm not going to do it in my head though.
So how are these economic benefits accrued? What is happening with the adoption of biotech that enables farmers to make that extra money per hectare?
Well, the technology delivers farm income benefits from two main routes. Firstly, there's improvements in yields. Now, there are higher yields. Out of that 98 billion, 51% of that has come from really lower costs and 49% from extra production and higher yields. So that's where it's broadly coming from. At a very broad level, most of the yield improvements have come from the insect resistant technology in corn and cotton, And the biggest yield benefits have gone to developing country farmers who've used insect-resistant cotton, especially in China and India. Again, if you look at that 98 billion, about 25 billion of that has gone to small resource-poor farmers in India and China.
Mm-hmm. And so with regard to the economic impact, you said that's from yields, but it's also from reduced inputs for farming. So could you talk a little bit about what the reductions are and why is that meaningful? Not only for the farmer, but also for society as a whole.
Well, on the farm side, it's mainly the herbicide tolerant technology. Its primary benefit to farmers has been lowering their cost of production, essentially reducing the amount of money they spend on herbicides on the economic side. There are also other economic benefits that have gone with the technology, which I call are non-pecuniary. They're a bit more difficult to quantify in monetary terms, such as making farmers' lives easier in terms of their management, enabling them to go into a no-tillage production system, but I'll talk a bit more about that later. But that's on the herbicide tolerant technology. Now, if you then take it to the environmental impacts, the adoption of this technology over that 16-year period has resulted in 473 million kilograms of pesticide active ingredient less being used on that biotech crop area than would have otherwise been used. In terms of the amount of active ingredient, that's a 9% reduction. Mm-hmm. To give you some context, that's roughly equal to about 1 3/4 times the amount that arable farmers in the European Union put on their farms in a year. So it's a lot.
It is a lot.
But the amount of pesticide that's put on the ground is a very crude and not a very good measure of the environmental impact. So what we do in the report, we also use an indicator called the environmental impact quotient. It was developed at Cornell University in the 90s. And this is a better measure. It fundamentally measures and relates to the toxicity of the different pesticides. So if you use that measure, those changes are actually an 18% reduction in the environmental impact. So you can see pounds on the ground, it's a 9% reduction. But more importantly, in terms of the benefits to the environment and to society in general, it's an 18% reduction.
Great.
Then if you move on to the greenhouse gas side, I always get asked, well, how do biotech crops benefit greenhouse gas emissions? Well, two main ways. Firstly, if you spray less, you're using less fuel in tractors in the countries that use motorized sprayers. Secondly, the herbicide tolerant technology has helped many farmers go from a plough to a no-till system. Now, ploughing is the single largest way that arable farming releases carbon into the atmosphere. When you plough, you release the carbon in decaying crop residues. So if you don't plough, it's stored in the ground. So that's the main second way. But to go into no-till, you've got to have good weed control, because ploughing is typically part of weed control. This technology, glyphosate tolerant technology, was one product which is broad spectrum, kills a lot of weeds, enabled farmers to get good, cheap, effective weed control. So they could go in a no-till, but more importantly, stay in it. So the no-till means you retain the carbon, and you're also ploughing less, so saving on diesel, and you're spraying less. So that is the way you've got the savings on the greenhouse gas emissions. Now, in terms of quantity, in 2011, the total amount of carbon saving that you can attribute to biotech crops has been the equivalent of not releasing into the atmosphere about 22 billion kilograms of CO2. To give you context, that's the equivalent of taking about 10.2 million cars off the road for a year.
That's wonderful. And we've just got a minute or so left, and I'm just wondering, are you aware of a technology in agriculture or outside of outside of agriculture that has had this broad spectrum of impact? I've been reading your reports for years, and it appears to me that each year the impact is increased, right? I'm assuming that's related to the adoption rate of biotech, but how significant is what we're seeing relative to other technologies that perhaps farmers have used over the last millennia?
Very significant. You can look at various pieces of technology that have come into farming over the years. For example, the introduction of hybrid maize, but the introduction of crop biotech in the mid-90s, I am not aware of any technology that's been adopted so rapidly and dominated certain crops and countries in such a short space of time as biotech. And we are actually only talking about 6 pieces of technology: herbicide tolerant in 4 crops, corn, cotton, canola, and soybeans, and insect resistance in cotton and corn. So for 6 pieces of technology to have that level of impact is, in my view, unprecedented.
Unprecedented, great. Thank you so much, Graham. It's been a pleasure spending time with you today. And I think that your report just highlights how important ag biotech is to the nation, to the world. Certainly we have folks here, thousands of folks here who are interested in learning more about biotechnology, investing, and I'm really thankful for you for bringing to us the information that is going to help us get where we need to be. It's because of you that we're able to talk about in so credibly the benefits realized from biotech. Thank you.
Thank you.